US Physics Olympiad, year 2023, first round, F = MA. In this year, it was given as usual 75 minutes for 25 problems. If you want to get more interesting problems, just subscribe for this channel. Problem number 1. A bead on a circular hoop with a radius 2 meters travels counterclockwise for 10 seconds and completes 2.25 rotations, at which point it reached the position shown. In the past 10 seconds, what were its average speed and the direction for its average velocity? Problem number 2. A mass on an ideal pendulum is released from rest at point 1. When it reaches point 2, which of the following shows the direction of its acceleration? Problem number 3. A soccer ball is kicked up a hill with a flat top as shown. The ball bounces twice on the hill at the points shown, then lands on the top and begins rolling horizontally. Which of the following shows the vertical component of its velocity as a function of time? Problem number 4. A box of mass m is at the bottom of an inclined plane with the angle theta to the horizontal and the height h. A person drags the box very slowly up the plane by applying a force parallel to the plane. The coefficient of kinetic friction between the box and the plane is mu k. When the box reaches the top of the plane, how much work has the person done? Problem number 5. Two blocks of mass m and a block of mass 3m are attached to a system of massless fixed pulleys and a massless string, as shown. Assume all surfaces are frictionless. What is the acceleration of each mass m? Problem number 6. A ball at the end of a rope of length 0.5 meters is swung in a horizontal circle with a speed of 15 meters per second. The other end of the rope is fixed in place. What is the height difference between the ends of the rope? Problem number 7. Two boxes are stacked side by side on top of a large box as shown. All three boxes have mass m. The coefficient of static friction between the left box and the bottom box is mu s, and all other surfaces are frictionless. Rightward force F is applied to the bottom box. What is the minimum value of mu s so that the upper box don't slide? Solution for problem number 7. Problem number 8. Two stars, alpha and beta, with masses satisfying m alpha over m beta = 10, are in circular orbits around each other. In the rest frame of this system, find the ratio of the speed v alpha over v beta. Problem number 9. A helium balloon is released from the floor in a room at rest. Then slowly rises and comes to rest, touching the ceiling. During this process, the gravitational potential energy of the balloon has increased. Since energy is conserved, the energy of something else must have decreased during this process. Which of the following is the main contribution to this decrease? Problem number 10. An archer takes aim at a target that is 100 meters away. Assuming she holds the ball at the same height as the center of the target and shoots an arrow with the velocity 100 meters per second, At what angle above the horizontal should she aim the ball so that the arrow hits the center of the target. Problem number 11. A projectile is thrown from a horizontal surface and reached a maximum height h and also lands a distance h from the launch point. Neglecting air resistance, what is the maximum height for a projectile thrown directly upward with the same initial speed? Problem number 12. A block of mass m is initially held in place by two massless strings, as shown. The tension in the diagonal string is T1. Next, the horizontal string is cut, and immediately afterward, the tension in the diagonal string is T2. Which of the following is true? Problem number 13. A uniform box with mass m is at rest on the horizontal surface, and the coefficient of static friction between them is mu s. A force directed at an angle of 85 degrees above the horizontal is applied to the center of the box with a linearly increasing magnitude F equal beta t. The box will eventually slide or lift off the ground. Which of the following is correct? Problem number 14. The object shown below is made of three rigidly connected identical rods with a uniform density. When it stands upright on a horizontal table, what fraction of its weight rests on the left leg? Problem number 15. The following plot shows the speed Vr at which stars orbit about the center of a galaxy as a function of their distance r from the center. Assuming the galaxy has a spherically symmetric mass distribution, which plot best shows the mass of the galaxy mr enclosed within radius r? Problem number 16. A bead attached to a string of length L equal 10 meters is released from a very small angle θ0 to the vertical. A wall is placed in the path of the bead such that the bead collides elastically with the wall when the string is at an angle θ0/2 to the vertical as shown. What is the interval between the bead's collision with the wall? Problem number 17. Three physical pendulums are built as shown. The first is a typical pendulum with a massless rope, and the second and third are made of uniform rods. What is the correct ranking of the moments of inertia I1, I2 and I3 about the pivot points? Problem 18. Alice, Bob and Carol are each given identical airtight bags containing identical rocks and a large tube of water with a scale sitting on the bottom. Each of them measures the weight of their bag and rock by putting the bag on the scale, using three slightly different procedures. Alice closes the bag carefully so that there is no air inside. Bob fills the rest of the bag with water before closing it. Carol closes the bag loosely so that it contains some air. What is the correct ranking of their measured weights, WA, WB and WC? Problem number 19. A student sets up a simple pendulum, measures its length to be L equal 0.5 no 0.50 plus minus 0.01 meters, and observes a period of oscillation of t equal 1.4 plus minus 0.1 seconds. Using this data, the students compute g equal 10.1 meters per second square. What is the uncertainty of this measurement? Problem number 20. A mass attached to the end of a string oscillates like a pendulum with a small amplitude. The mass has a horizontal velocity vx and a vertical velocity vy as functions of time. Which of the following could be a graph of the curve vx and vy over a complete oscillation? Problem number 21. Smooth ring of radius r and mass m lies on a frictionless surface. A point mass also of mass m is placed just inside the ring and given a speed v tangent to the inner surface of the ring. How long does it take for the point mass to return to its initial position relative to the ring? Problem number 22. Two springs with different spring constants are connected in three ways as shown. In the second case, the springs are connected to opposite ends of a string which runs under massless frictionless pulley. In each case, the two springs act like a single spring with an effective spring constant Ka, Kb or Kc. Which of the following is correct? Problem number 23. An astronomer on Earth, which is a distance LE from the Sun, observes a star and galaxy. The star is a distance LS much greater than LE away, and the galaxy is much further away than the star. Throughout the year, the angular distance between the star and the galaxy appears to vary, reaching a minimum of 2 astroseconds on January 1st and a maximum of 2.5 astroseconds on July 1st. 1 degree is equal to 3,600 astroseconds. Assume the Sun, star and galaxy do not move relative to each other, and that the Earth's orbit lies within their plane. What is the ratio LS over LE? Problem number 24. A very heavy plate continuously moves up and down with a small speed v, switching directions after each time t. At a random time, a ball is dropped from rest far above the plate, then bounces elastically off of it. How does the ball's speed change during this collision? Problem number 25. A skier slides from rest along a frictionless slope with the incline angle theta equal 30 degrees for 150 meters. Then smoothly transitions into a horizontal jumping ramp of height hr equal 5 meters. Neglecting air resistance after the skier leaves the ramp, about how far will they travel horizontally before landing?